this lecture we are going to describe the superheterodyne receiver. So that is the block diagram of the superheterodyne receiver. So here we have FM broadcasting signal, and the range of the audio signal is 540 to 60, 50 kilohertz. So that is the antenna, receiver antenna. So this one is the RF amplifier, and this is the mixer. So mixer is the main block making it superheterodyne. So what is the benefit of using that receive antenna? So we know that the receive antenna is used, like receive antenna is used to convert EM waves into electrical signal. So that is the purpose of the antenna. The second is the RF amplifier. So RF amplifier have many advantages. The first one, it provides gains. The second one, it improves sensitivity. Sensitivity is the reception of the weakest signal. The third one is it provides better signal to noise ratio. Fourth one, it provides better selectivity, and the other one is provides image frequency rejection, and it provides better coupling to the antenna. So the second block is the mixer. So if we open the mixer, like here we can see, okay, we are getting RF signal, so RF amplifier. So if RF amplifier is giving us these values, cos omega mt, and the output of the local oscillator is cos omega lt, and this is the product multiplier. So this is basically mixer, and so that one is the product multiplier. So it means that the output of the product multiplier means, so if this is A and this one is B, so the output of the product multiplier output will be equals to A multiplied by B. And the bandpass filter is known as a synchronous detector. So it is working as a detector, so it will reject the high frequency and it will allow pass the low frequency. So what is the output of the PM modulator? So if we represent the output of the PM modulator, like we can say that the if it is output is represented as YT, so then YT is equals to AM cos omega mt multiplied by cos omega lt. So this is a trigonometric function cos, so cos alpha, and this is cos beta, and we know that 2 cos alpha into cos beta is equals to cos alpha plus beta plus cos alpha minus beta. So if you use that formula here, so we can multiply and divide this term with an other factor, and then so it means that this will look like that. So we can rewrite that AM over 2, so cos omega L plus omega M plus cos omega L minus omega M. So this is basically the output of the product modulator. So but if we are using the band pass filter, so band pass filter is working as a detector, and it will reject the high pass frequency, and then in that case the output will be, the output of the band pass filter will be equals to AM by 2 cos omega L minus omega mt. So that is the output of the band pass filter. So if we give that to the IF amplifier, so the function of the IF amplifier is limited and the limited frequency is 455 kilohertz. So it means that the output of the mixer, it can be FL higher frequency, FL plus FM, or FL minus FM. So that frequency will be rejected out and the remaining is FL plus FM. So it means that whatever the value of FM, we should adjust FL such that the output of the intermediate frequency, the output will always be equals to 455 kilohertz. So it means that, so the frequency of that particular block is, you can write Fi, like the intermediate frequency, IFR, Fi. So Fi will be equals to FL minus FM, or you can write in term of FL, so FL is equals to FM plus Fi. But suppose if you have another message, so that is F bar M, so which is equals to FL plus Fi, and we know that FL is equals to FM plus Fi, so you can use that value here, FL, so it will be equals to Fm plus Fi plus this Fi, that is equals to Fm plus 2Fi. So this is again an image frequency. So this is a problem, like it will create a crosstalk and we have to adjust it. So if we take another example, like in numbers, so suppose the first message have a frequency of 600 megahertz, 600 kilohertz, and the frequency of the local oscillator, if we add 600, so 600 plus 455, the answer is that one. So that is 1055. Like that, we need to adjust Fm, that whatever the Fm is, the Fi should be 455. So for that 455, the Fl should be 1055. And for another message Fm, so Fm bar is equals to Fm plus 2Fi. So Fm is 600 plus 2Fi. So Fi2 is 455 multiplied by 2. The answer is 910. So 910 plus 1600. So 910 plus 1600 will give you 1510. So if your local oscillator is still, it is 1055, and in that case your Fi is equals to, so your Fi is equals to this Fm this minus that, so Fl minus Fm bar. So Fi is equals to Fl minus Fm bar, so which is equals to 4 minus 455 kilohertz. So you can see that it is again the crosstalk or the image frequency. So it means that it can be a crosstalk or it can be a problem for the systems. So how can we adjust? Like we need to adjust this type of issue. So it means that better to select FM 800 kilohertz. So if Fm is 800 kilohertz and Fi is 455 kilohertz, so it means that 800 plus 455 will be equals to 1255. So Fl is 1255 kilohertz. So if Fl is 1255 kilohertz, then your Fm bar, like your second message, so this is first message, so this is second message, the frequency of the second message is equals to 1255 plus 455, like 1255 plus 455 will give you 1710. So this is not a problem. Like we know that the range of the AM is 450 to 1650 kilohertz. So it means that this signal is already out of that range. So it means that it will not, the band pass filter will not allow to pass this signal. So it means that our problem is adjusted because the frequency of the local oscillator has been fixed, has been already tuned. So whatever the FM is, so it will not the problem for us. So RF amplifier is tuned with the help of a variable capacitor, like here. So you have mixer, a local oscillator, and the local oscillator is tuned with the help of a variable capacitor. So this is known as, so this variable capacitor is known as gain capacitor. So you can also say it a tuning or tracking capacitor, like the frequency of the local oscillator is fixed now, and then you are just going to tune this capacitor, and you are getting different FM channel. In that case, Fi is already fixed and C is variable, and then your problem is solved. The remaining is demodulator. So demodulator is a sub-receiver. So after the demodulator, you have audio voltage amplifier, which will amplify the signal, and then power amplifier, which will amplify the power, and then after that you have a loudspeaker again. Like the loudspeaker will take the electrical signal and it will convert the electrical signal again into the physical signal, like giving you the vibration depending on the frequency. So that is all for the super heterodyne receiver. I hope that you understand it very well. But if you still have any question or any suggestion, so you are most welcome in order to improve that video. So please give us a comment so that we can improve the quality of our lecture. Thank you for watching the video.